Welcome, everybody. This is Kamesh Pemaraju at Platform 9. We are excited to have a webinar today with the FinOps ambassador, Dieter Matzion. We're going to talk about cloud usage and cost efficiency, a big topic of discussion happening in the market today. If you guys are part of the FinOps organization, you've seen how quickly it has grown over the last 2 to 3 years. The FinOps event that's coming up in June, from what I hear, Dieter, the attendance there has doubled just in the last 1 year.
Yeah,
so just a big explosion in interest for all the obvious reasons, right? There's the economy, people trying to optimize their costs, and way before, cost has always been an issue, right, Dieter, in the public cloud. Why is it now it's become such a big issue, and why is everybody focusing on it?
I think macroeconomic climate downturns, right? Those kind of factors, and during the pandemic, the U.S. federal increased the interest rates multiple times, right? I think something like 12 times. So to prevent inflation. So now we are coming down from that, and there's concern about a mild but prolonged recession.
So there is talk about recession,
Absolutely,
which can negatively impact a lot of the economic factors here. So why don't we just jump to the next slide? The reason I'm super excited to have Dieter is not only he is a FinOps ambassador and part of the FinOps Foundation, very active, certified practitioner of cloud FinOps for many years now, a couple of years, right, Dieter?
Yeah, since the program started, essentially.
Yeah, so right from the beginning. But even more exciting or interesting or valuable, in my opinion, is he's been actually doing work at companies like Roku, Intuit, Netflix, and Google, where he's actually applied some of these practices. And he's got real world experience of what works and what doesn't work, and kind of bring that back into the FinOps framework, right? The way the FinOps Foundation has been talking about the framework and how that applies to the real world. And that's really what I'm super excited to have Dieter walk us through. And again, just as a quick introduction, I'm Kamesh Pemaraju here at Platform 9. I run marketing, and we've been doing a lot of work in FinOps in the recent months, and this is, we're looking forward to this conversation with Dieter. So Dieter, why don't you take it away? And I would say all along the way, if you have questions for Dieter, feel free to ask, in the Q&A window in the Zoom webinar down there. And as questions come up, I'll bring them up, Dieter. And if it's relevant, you can answer them along the way. And of course, we'll have Q&A towards the end of the webinar as well. So with that, I'm going to hand it over to Dieter. Maybe it's a good thing. Maybe you start off with your background here, so everyone knows, what you've been up to at these companies and how you've been applying FinOps principles in the real world.
Yeah, absolutely. Yeah, thank you so much, Kamesh. Yeah, I will be your host today. I've been working on cloud FinOps since 2013, as you guys can see here. Google, Netflix, Intuit, and most recently Roku. I have worked at other companies before, but they were not in the cloud. Like PayPal was directly before Google, but we used data centers back then, right? So I have quite extensive experience at large organizations, and we will have some case studies about these organizations as well, like what were their challenges in the cloud and how did they overcome the challenges, right? I'm also one of the FinOps ambassadors, which also means that I'm a cloud FinOps certified practitioner. That is something that you guys can achieve as well. There's other certifications from the FinOps Foundation, like a FinOps certified engineer and professional and those kind of certifications, right? So now, if you guys have any questions, like Kamesh said, there is a question and answer section, and we'll see your questions there. There's relatively few attendees, so we could potentially open up for voice as well, so we can have a conversation over voice. So just let us know if that is interesting to you and if that is needed, right? I'm going to start with talking about what is FinOps and why is it so important, right? A lot of people may not know what FinOps even means. FinOps is actually a word blending between finance and DevOps. It is not finance and operations or financial operations, it's finance and DevOps. So a lot of people don't get this right? Here is the official definition of what FinOps is by the FinOps Foundation as of last December, right? So this is fresh off the press, so to say. And I promise that's the only thing that I'm going to read off, right? But I feel I need this to read this off so that you guys have a better impression of what FinOps is. And I will go into more detail in just a minute. FinOps is an operational framework and cultural practice which maximizes the business value of cloud, enables timely data-driven decision-making, and creates financial accountability through collaboration between engineering, finance, and business teams. So now that we know what FinOps is, here's the FinOps framework. Don't worry, I'm not going to go through the framework, right? I will just touch on the highlights, but you can see in the bottom left, there's core personas, then come allied personas, phases, and maturity, and in the top right, you have the domains and capabilities. As you see, these are, there's many capabilities within FinOps, and this has been updated just this March, in March 2024, right? As I said, I'm not going to walk you through all of this, but I want to still give you a feeling of what FinOps is, how it feels, how it looks, and how to operate within FinOps, right? So what I'm going to do is I'm going to walk you through the FinOps principles, and we see those here. These principles are in no particular order, and they are sort of guiding North Star goals, right? This is what you want to do. This is what you always strive of doing. And it will give you an idea about FinOps, right? About the core values of FinOps and how it works. Let's start with that the decisions are driven by the business value of cloud, right? That means decisions are not driven by personal preferences, concerns, fears, those kind of things, right? You always try to have a business value. And I think in general, this is a good idea. If you do something in a business, then you want the business value to drive those decisions, right? And I see here we have feel free to ask questions. Yeah, okay, excellent. So now we are driving our decisions through the business value of cloud, and what we need to be able to do that is data. And this data should be accessible and timely. For example, if an engineer does an experiment, the engineer does not want to know the cost of this experiment at the end of the month, right? They want to know it ideally within hours or maybe the next day, right? But showing the effects of an experiment at the end of the month is not useful, right? The next one that is the guiding principle is that everyone takes ownership for the cloud usage. So in a historical DevOps environment, you have the continuous integration and continuous delivery pipeline and the people, the engineers performing DevOps, right? And then you have site reliability engineering, where the engineers throw the workloads in the production environment, and then they magically become the responsibility of the site reliability or SRE team, right? This is not the case when it comes to FinOps. The engineers are being held accountable for the cloud usage, right? And they own that cloud usage. To be able to do this, there is a lot of collaboration required, right? And we mentioned collaboration in the definition of FinOps, that collaboration is the engine of FinOps. Often, you need to be able to achieve goals cross-team, cross-functional units, cross-business units, right? So collaboration and partnership is key to be successful when it comes to FinOps, right? So if I go to an engineer and I say like, hey, you have a cost spike, the engineer has to take ownership for that and investigate the cost spike, right? The engineer can't just shrug their shoulders and say like, it's not like it's coming out of my wallet, right? So that would be a violation of these principles to make this work well. And we are actually going to go into a lot of detail on how to do that in one of the last slides, where I walk you through what you should be striving for, what you should be aiming for to achieve this cross-team collaboration, right? The next one is to take advantage of the variable cost model of the cloud. The cloud has a couple of principles that are unique to cloud that don't exist in the data center and may not exist anywhere else. One of them is that when you turn a workload off, you stop incurring a cost. Certainly not true in the data center, right? The other principle is that the resources in the cloud are typically sized in t-shirt sizes, so small, medium, large, extra large, like that, right? And that is the elasticity that, let's say you need a resource that is of a small size. If you need more of that same resource, you can switch to a medium size, and for the most part, this will double your cost. And then again, if you switch from a medium to a large, it will again double your cost and provide you twice the amount of resources, specifically CPU and memory, right? And lastly, as a guiding principle here, we have that the centralized team drives FinOps. That is important. That imagine your organization has several business units, let's say a dozen, 12, right? If each business unit has their own FinOps team, these FinOps teams will then optimize for their business unit and not find a holistic optimization across your organization, right? There is simply no incentive. So to be able to optimize across all business units, you need to have a central team that drives FinOps. I also have here some notes that I'm going to review, but we are going to go to the next slide. Oh yeah, this is my favorite one. So what are the things that we can do to influence cost in the cloud? This is rate and usage optimization. All right, what is the rate? Let's say the rate, this is actually the basic cloud equation, right? Rate times usage equals cost. So let's say the rate is $1 per hour and the usage is 24 hours. The cost will be $24. Pretty simple, right? Rate optimizations can be generally executed centrally, maybe by the FinOps team or by a slightly larger team than the FinOps team, including finance, including leadership when it comes to signing contracts and those kind of things. Rate optimizations are generally achieved a little bit easier as a result because they can be done by a central and relatively small team. Usage optimizations, and we are going to talk about examples of rate and usage optimizations next, right? But usage optimizations simply have to, they can be surfaced centrally by the FinOps team or by a business intelligence team, right? However, the implementation of usage optimizations have to be done decentralized by the engineers. And therefore, it is a little bit more challenging. To empower engineers, you need three things. First, the engineers need the permission to spend time on optimizations. That may not always be the case. Permission from leadership. So leadership needs to buy in that these optimizations are important. And we are going to talk in more detail on how to do these things. The engineers need to know how to interpret usage optimization recommendations. They simply need to know what to do for each recommendation type. A recommendation type could be an idle resource, an underutilized resource, things like that, right? And as a result, usage optimizations are generally a little bit more challenging. Now, as we go and look at what are rate and usage optimizations, let's start with rate optimizations. An enterprise agreement is typically a contract between a cloud provider and one of its customers. And the contract, there's always three factors in it. The customer commits to X amount of usage over Y amount of time for a discount Z. So let's give an example, $100 million over 3 years for a 15% discount, right? Those are the enterprise agreements. However, all cloud vendors, and that is true for Amazon Web Services, Google Cloud Platform, and Microsoft Azure, they have additional programs, right? And lots of them. So it is worth to reach out to your cloud provider account management team and ask them about these programs. The program that is most commonly known is the Migration Acceleration Program. Historically, it originated with workloads migrating from a data center into the cloud, right? And then, the cloud provider would typically recognize that, yes, there is an engineering overhead where X amount of engineers cannot perform for Y amount of time. And the cloud provider then provides a credit in the amount of Z to help with that migration, right? To accelerate that migration. When it comes to migrating, shorter is better than longer. I have talked to people that had a cloud migration plan of 36 months. Try 6, try 12, something like that. These are more successful. To be able to fail fast, you need to work fast, right? If you produce one deliverable per month, the only thing that you can do is fail slowly. Next one, which is a little bit less known, is private rate cards. These private rate cards are service-specific discounts. Let's say your organization has a very specific usage in a service like a blob storage or an object storage. And again, it will follow X amount of usage over Y amount of time for Z discount. So for example, I'm committing to 100 petabytes of simple storage service usage over the duration of 3 years, and I get a 25% discount for that. This is just an example, right? So, and this discount then will supersede the discount in the enterprise agreement to give you an idea of what is happening behind the scenes, right? Now, when it comes to savings plans, these are publicly available products, savings plans and reserved instances, right? And the best way to envision it is, let's say you get like a magazine or something like that, and it has a coupon to eat at participating restaurants, and you get 20% off, right? So you can tear that coupon out. You now have your 20% off coupon at participating restaurants, and you can go, let's say, to an Applebee's or to a Burger King. You can buy your meal, put the coupon on the table, and you get 20% off. In the case of cloud, these savings plans apply across different products, right? So they will apply against, let's say, compute usage, against serverless functions, and so forth, right? So the savings plans are more flexible, and however, the discount percentage is more limited as a result. Reserved instances, on the other side, imagine you get a coupon that is Applebee's specific, right? But now you get 30% off. Now you take this coupon to Applebee's, 30% off works perfectly. You go to Burger King, they will say, we don't recognize this coupon, right? So reserved instances typically provide deeper discounts compared to savings plans, but they are much more specific. On the usage optimization side, we now have a couple of things here too. The first two are the most interesting because they affect unit economics, right? Many times people ask, what is unit economics? How do I do unit economics? Unit economics, in a very, very basic form, is simply the cost of vCPU hours plotted over time, right? So you take all your vCPU hour usage in a month or in a week or in a day, and then divide it by the cost, and you get a factor of how much a vCPU hour costs. Ideally, you want to see this graph go down over time, right? And one way of achieving that is using microprocessor architectures other than Intel x86, right? Intel x86 is sort of like the flagship solution. There is other solutions like going to AMD microprocessors or going to ARM-based microprocessors. On the AWS side, this would be Graviton microprocessors, right? And Graviton is generally cheaper and also more performant. And that is because Intel x86 is having hyperthreading. Some workloads like encoding, encryption, compression have to be performed on physical cores and cannot be performed on hyperthreaded cores. So Intel x86 CPU utilization is typically limited to somewhere 60–70%, after which the operating system will become unstable and unresponsive. While ARM-based microprocessors also have a form of hyperthreading, they don't suffer from the same things that Intel suffers from, and you can safely run them at 90% CPU utilization. Now, storage lifecycle management is the simple principle. You track gigabytes stored or the cost of gigabytes stored over time, and ideally that graph should be trending down, which means that your engineers are using cheaper storage options over time, reducing your overall total cost of ownership in the cloud. So storage options range from hotter ones to colder ones, and the idea is to use storage lifecycle policies to move from hotter storage options to colder but cheaper storage options. Right sizing, probably everyone has heard, right? Let's say you're running a workload on a large resource, and you look at, I'm only using 10% of the CPU. So if I want to reduce this to a medium resource, my CPU utilization will go up to 20%, right? And then you maybe can even do a one step more, go to a small resource. Now you have 40% CPU utilization, assuming that the memory still is there, that you're not having any issues with having too little memory. Cloud parking and cloud schedules is very simple. If your organization is, let's say, country specific, and you don't need to work outside of business hours, then you can turn the resources off outside of business hours, which typically results in 60% and more savings. Challenges in right sizing. I see an answer here from a question here from Anand. I'd like to answer that. It's typically visibility and being able to execute. One thing is with visibility that the hypervisor exposes CPU utilization, but does not expose memory and disk utilization. You also get network utilization from the hypervisor. The hypervisor is the piece of software or hardware that is allowing for the virtualization, right? So a lot of times the recommendations, and I'm going to talk about that in just a moment, the recommendations are coming through not knowing what the memory requirements are of the application, right? So, and then the engineers need to know how to replace that workload. And I'm going to walk us through that as well. Last is re-architecting. Re-architecting is simply taking an existing application and rewriting the code. And I've seen examples of an application that was running for $5,800 a month, and the engineer just rewrote the code, put some cache in front of it, and now the workload is $80 a month. So very substantial savings can be achieved here, right? And so that is something that is probably the most profound when it comes to optimizations. Now, let's take a look at the optimization landscape, right? That is what is probably the most interesting. What are all the different tools that exist to optimize things? So when we look at the landscape, there is literally a galaxy of tools out there, and it is important to understand what the capabilities of these tools are and what the limitations are. We see here that the examples given range from identifying idle or underutilized resources to making right-sizing recommendations. And we already talked about that some of these right-sizing recommendations, so for example, Trusted Advisor from AWS, does not have visibility into memory and disk utilization. So whatever recommendation Trusted Advisor surfaces, it assumes that you're using all of the memory, even if that's not true. And then it does recommendations simply on the CPU right sizing, right? And then you see some tools surfacing that can do recommendations and execution of the recommendations. Those are the tools that you're looking for, right? And then there's also some corner case tools, right, where we have, in this case, Spot by NetApp, that for a Kubernetes cluster at any given hour, it chooses the most effective or cost-effective virtual machine option, right? So again, there is thousands of these companies with tools. Today, we are talking about Platform 9. And let me walk you through what the typical challenges are. When you look at a historic data center CI/CD pipeline, right? These pipelines get executed maybe once every few weeks or once every few months. There is a heavy QA process. Typically, it is called smoke testing for a light QA process, right? Or a end-to-end QA testing process. And then the configuration change needs to be somehow deployed in the production environment, which means there could be a service interruption, even if it's small, just a few minutes, that kind of stuff, right? Even if you are a company like Google or Netflix, where all production changes get pushed into the CI/CD pipeline, and it runs continuously 24 hours a day, and it can make those changes seamless, right? There is still a chance that a change has adverse effects, maybe with other changes that were happening at the same time, right? Or with portions of the code that the engineer was not aware of or didn't work on, and you will have to roll back those changes, right? So keep in mind that this is a, still for the most part, a vastly manual process, right? So let us walk to the challenges of low resource utilization, right? Here's a couple of reports. I swear that I'm aware of a Flexar report in 2012. So cloud started in 2006 with AWS, 2008 with Google, and 2010 with Microsoft Azure, right? So 2012, but I wasn't able to find the Flexar report. Maybe it has been taken down and replaced by newer reports. But you see here, even though these are slightly out of order, you see here that for the better part of a decade, organizations have been estimating that about 30% of the cloud spend is waste, right? So if you are spending $100 million, we're looking at $30 million, right? So now I think here is the reasons for low resource utilization in the cloud. And you guys can read that by yourself, right? And I mentioned before, there is a couple of things in the cloud that you want to take advantage of. Being able to turn a workload off and not being built for it. And the elasticity of that the resources are flexible. You can go small, medium, large, and backwards. This is what you want to take advantage of, right? So let me give you here an example of a typical mindset of a software engineer that comes from the data center, right? In the data center, you purchase the hardware, and it is typically purchased for an amortization schedule of 3, 4, or 5 years, right? After the amortization schedule of the hardware expires, the hardware then is being taken out of the data center and sold to a secondary market, right? And refreshed with new hardware. So that's how data centers work. When an engineer builds a workload for a data center, they know that the hardware is sized for the workload to grow into the hardware over the duration of the amortization schedule. So the engineer, what is the engineer word? There's a couple of things, but most importantly, the engineer doesn't want to get paged outside of business hours, right? So now is the engineer going to get paged, let's say for a shopping cart application on a business day outside of business hours? Likely not, because the shopping cart application will be low utilization, right? After business hours on a regular weekday. But on the weekend, there may be a commercial, a marketing campaign, and the shopping cart application explodes, right? And the engineer gets paged, and engineers don't want to get paged on the weekend, right? They want weekends like everyone else. So the engineer will size this workload out of, to start out with, right? 2-3 times higher of what it really needs, right? And then the manager of the engineering team knows that most of his engineers size their workloads correctly, but some don't. So the manager adds 50% buffer on top of that. Then the director comes and the director says like, hey, I want my department to look good. Let's put 30% buffer on that, right? And then the VP comes and says like, well, we should be really conservative here and add another 15%. By the time this workload is in the data center or the cloud, it is sized typically 5 times more than what it needs to be. And you see that at the average CPU utilization is typically less than 10%, right? And that's a problem that can be overcome. Let's take a look at what we can do here. So here's a case study of Intuit, one of the companies that I worked for. And so Intuit is famous for its tax software, right? In the United States, tax day is on April 14th. So for some reasons, psychological reasons, right? You can't submit your taxes as early as January 1st for that year, for the last year, right? But April 14th is the deadline, right? So most people do their taxes like a week or two before, and we are talking about, hundreds of millions of people that are submitting their taxes. So Intuit in the data center, we had to have the workloads scaled for tax day, right? In the data center, you don't have the ability to just scale out infinitely. You need to buy the hardware, you need to configure the hardware, and the hardware needs to stand there. So in 2014, TurboTax moved into AWS, and the savings were 6x, right? So 6 times cheaper to run this in the data center. When I started in 2016, so just 2 years later, we used 6 waste sensors, and waste sensors are little scripts that are collecting data in the cloud, either using APIs or making their own calls, and storing this data in a central repository, right? So with 6 waste sensors, we determined 25% waste. So a little bit better than industry average, but of 30%. But at that time, Intuit was spending about $100 million annually. So 25% is $25 million, right? Over the course of 4 years, by 2020, when I left Intuit, we had 34 waste sensors and below 5% waste. I think it was like 4.7, something like this, right? So we were able to reduce the waste substantially. We cut it down by a factor of 5 while increasing the bar, while increasing the visibility into waste, right? Which is really good, but it still shows you that, first of all, 5% is still a quite large number, and 4 years is a quite long time duration, right? So we need solutions that are a little bit better than that. So let's take a look at, actually, I think we have the QuickSight KPI dashboard. So if you happen to run on Amazon Web Services and you have access to QuickSights, there's a Kudos dashboard. Kudos is spelled with a C, and the Kudos dashboard has this KPI dashboard with it. And so here's a good example for tracking waste for free, right? You can install this for free. This comes at no cost. So the on the right-hand side, in the right-hand table, the first line item is EC2 previous generation. That means you're using older virtual machines. Older virtual machines are typically less performant and more expensive, right? And then the third line item, you have EC2 Graviton. You show here, this is the ARM-based microprocessor architecture adoption. And then a couple lines down, you have S3 standard. This means you're using the hottest storage option. And so we are here at 40%, which means that 60% of our storage is on colder storage options. So now let's look at challenges and strategies for optimizing cloud infrastructure. What are some of the root causes, right? When you think psychologically, an engineer, and again, you can read those bullets yourself. When an engineer sets up an experiment, they have some idea, they write some code, and they build an experiment in the cloud, right? And that is what we want them to do. We want them to have this flexibility to innovate. But we need to also look at the psychology of that. If the experiment is unsuccessful, that engineer will dismantle the workload or the experiment almost immediately, right? Because they want to avoid shame. They don't want their coworkers to make fun that their idea didn't work out. However, if the experiment is successful, this experiment will be left around for days, weeks, or months, so that this engineer can show this workload to other engineers, right? This workload may not be doing anything useful. It may even be configured in a production configuration where it is meant to take, 1,000 requests per second. And in reality, the experimental workload takes 5 requests a week, right? So it's a waste of resources. Think of it this way. Some people ask me, when are you done with FinOps? You can't be done as long as people are working, right? If people are working, then it's like an industrial kitchen, not like a kitchen of the local restaurant that you go to, but a kitchen that provides meals for, let's say, a retirement home or something like that, right? That has multiple cooks. One works on appetizers, the other one on the main course, the other one on desserts, right? At the end of the day, this kitchen will be quite messy, right? It has to be cleaned up every day. And the same is with the cloud, right? As long as you have engineers working in the cloud, you need to clean up their messes, right? Now let's go to the next one where we look at the cost-saving challenges, right? I already mentioned the t-shirt sizes, small, medium, and large, right? And that you can take advantage of these. However, what if your application needs in the evening a small size resource? And again, please read through these yourself, right? But during the day, it needs a large size resource, right? You have to scale this application somehow. And doing this manually is going to be extremely challenging, right? Just to go and change either the auto scaling rules, right? So you can scale horizontally, you have more resources of the same type, or you can scale vertically, which is you have different size resources of that type, right? And to do that automatically is the way to go, right? If you try this manually, it won't work. And often the engineers are used to manually provisioning resources in the data center. So when they come in the cloud, these practices persist, and the engineers keep, having resources, manually provisioned in the cloud, which is not what you want them to be doing. Next, let's take a look at some of the strategies, right? I think in my mind, the best strategy for overcoming all of these challenges is to adopt a containerized workload, right? Because containers give you a couple of things. One is that when you switch your workload from, so to say, legacy virtual machines into a containerized workload, right? You get more statelessness. So what does this mean? Let's say you have a monolithic application, the monolithic application keeps customer data in memory across multiple customers, right? And while in a containerized workload, you spin up a container for each customer. So you have 10 customers, you get 10 containers, and each container only needs to have the context of its customer, right? And once the customer interaction is satisfied, the container simply gets terminated. So the containerized applications become stateless, and you get more options in optimizing horizontally, getting more containers, or vertically sizing the containers on the fly, right? And just to explain to you, let's do a little bit of an example of when I worked at Netflix, right? Netflix in 2015 spent about $250 million in the cloud. And they had one engineer that was responsible for tuning auto-scaling rules only, right? So at 250 million, they were able to pay one engineer 250,000 annually, and that worked for the business. However, let's look at auto-scaling, right? Let's say that there's pressure on your workload, so you scaled it out, right? and now the pressure subsides, so you want to scale it back in. But you don't know if there will be a spike soon thereafter, right? So as you're scaling back in, another spike of requests could reach that workload where it is currently in the process of shrinking, and you need to instead expand it again, right? In this case, you get race conditions, right? And this engineer that worked on tuning the auto-scaling rules was a very senior level engineer, very knowledgeable and capable of, comprehending these and anticipating these race conditions, right? However, I also have to say that this is very monotonous work, right? And you cannot expect that a person like this, an engineer like this, right, is going to stay at this company for like 4 or 5, 10 years, right? They are going to look for something else to do 18, 24 months down the road, right? So again, the best way of handling these situations is to simply go to a containerized workload, and because it gives you more flexibility. Think of virtual machines as being just a stopgap going from the data center into the cloud, and then look for more cloud native technologies. Now,
Hey, Dieter,
yeah, go ahead.
I have a question
Yeah,
about containerization. So one of the things that I was wondering was as companies move from data centers to the cloud, what, from my experience, I find that they take an existing monolithic application,
that's right.
like a large VM, and basically throw it out there in the cloud. Either they do that or they take that VM and containerize it. So it's still a monolithic application, not
Mhm.
really stateless, not, it still has some state and databases and stuff
Yeah.
like that. Do you see that happening? What is your general sense for the type of applications that are running where
Yeah,
FinOps becomes an issue?
in my experience, lift and shift is the most frequently executed pattern, right? What you are talking about is that they would have to containerize the workload in the data center first. And there's some good examples of that, right? Of running VMware vSphere in the data center that help you then migrate into the cloud. But if you're not there, and Intuit was not there, right? We had actually TurboTax, portions of TurboTax were written in C, not C++, not C sharp, C, right? And to be able to move, again, you don't want to spend 24 months on your migration to the cloud, right? You want this done in like 6, 8 months, ideally. And there's many reasons that we can go into, but unfortunately, we don't have the time today, right? But lift and shift, it's like poop in, poop out, right? You take whatever you have, you put it in the cloud, now it's in the cloud, now you start worrying about it. That is what I see more frequently, right? And then to go from that monolithic applications into a containerized solution. I have seen monoliths in the container, but as you can imagine, then you can't use interruptible VMs, right? There's a lot of restrictions. You cannot maybe change VM types, right? Yes, you're running on Kubernetes, congratulations, but it's still not good, right? You still can't use many of the things. There is some stuff that you can do when it comes to horizontal and vertical scaling, which is better than before, than just using VMs. But there's restrictions that your application has that you simply can't overcome. Did that answer your question?
Yes, thank you.
Yeah, yeah. All right. Now, organizational challenges in implementing resource utilization principles, right? So we have internal and external challenges, right? Internal challenges is, what does everyone want psychologically, right? I want to do my same job until I retire, without any changes, and I want my priorities to be outside of work with my family or friends or hobbies or sports or something like that, right? But I also want to get annual merit increases, right? So salary increases, for example, right? And that is not that realistic, right? I already mentioned that what is important here is the engineers view cost as another dimension they need to optimize, right? Engineers are already used to optimizing the applications. They look at latency, right? How long after someone clicks the button do they get the response, right? Is it 2-3 seconds, or is it 10-20 seconds, right? Let's say you're on a Roku home screen and you click on a movie, right? Do you want to really wait 20 seconds for this movie to start playing, or do you want to play almost immediately, right? So engineers are used to optimizing things. We just need to explain to them that in the cloud, they now need to learn how to optimize cost as well. Cost has to become just another dimension that the engineers optimize, right? And when it comes to external challenges, one thing that I have done this since 2013, right? So I was not there in 2006 when cloud started, but I have been doing this for over 10 years, right? And one thing that I can tell you is that there is every cloud provider either releases new products or releases new features to existing products, and sometimes even changes to existing products, most of the time for the better, right? So it requires a continuous mindset of learning and improving, right? You can't just have this mindset, hey, I'm going to do this job until I retire and I don't have to learn anything new, right? So those are the two things that we are generally working with or fighting against in a sense, right? So now let's take a look at how we can actually overcome these challenges, right? And from my perspective, it's a cultural change, right? FinOps is a cultural change where engineers optimize and take ownership of their workloads. That foundational, that's what it is, right? But how do you do that? Let's look at human psychology again, right? When you have a team, what are the teams that are working the best with each other, that bring out the best skills, the best ideas, the best features? Those are teams that where people feel comfortable when you say something that others won't make fun of you, won't laugh at you, won't judge you, right? And this is foundational what we want to achieve, right? The cloud is a new environment. Requires a lot of collaboration. It is ever changing. It needs to be continuously cleaned up. FinOps never ends, right? There is collaboration is really the engine of FinOps. You need people to feel comfortable to work in this environment, right? So what you need to do is you need to foster a culture of continuous learning, right? There is always new stuff coming up. If an engineer gets certified 10 years ago, that certification is 50% useful today, right? Because of so many changes. It's still useful. It's still good, right? But you need to continuously learn. You also need to foster a culture of continuous improvement, right? You can't simply say, hey, I want to do this job until I retire. You need to improve, you need to get better, you need to learn more. That's just the nature of how things are now, right? In the cloud. If you work somewhere else, maybe not so much, right? Although automotive industry is having changes as well, right? Where you now need to use computers to analyze what's wrong with your car. You also need to foster a culture of knowledge sharing, right? And this knowledge sharing can actually help break down organizational silos, right? People like to build, especially leadership likes to build fiefdoms, right? The manager has his team and he doesn't want to necessarily worry about the problems of other teams. A director has his organization and the other organization is separate, right? A business unit is separate from the other business unit. The knowledge sharing foundationally, if you do, let's say, a brown bag, right? People bring their food over lunch and they attend a session where one engineer is going over a learning. They had some experiment and they walk the audience through that experiment. They explain the technical details, what were the challenges, how they were overcome, right? Or tech talks, right? Have those regular things because they allow you to go across business units to break down those organizational silos, right? Because let's say business unit A is giving such a tech talk, but they invite all the engineers across all business units, right? So you foster this learning and the knowledge sharing, right? And you also need to foster a culture of continuous optimization, right? You simply can't have a workload that you built 10 years ago run identically in the cloud today, right? That's just not feasible. You should look at improvements to that workload. Can we put a cache in front of it? Can we containerize it? Can we split up the containers into microservices? Does this make sense? Will we have data transfer overhead that is not worth the microservice split up? Some workloads are perfectly fine being a monolith as long as they are stateless by themselves, right? So you could have a monolith for each customer request. That could be actually a faster way of doing things, right? However, you need to think about those optimizations and find the best ways of optimizing something. Okay, I think this is it. We are now open for the Q&A section. And I will bring it up on my screen. You guys can also put stuff into chat if you want, or we can just talk. Voice. Let me see who we have here. Madura is here. Hi, Madura. How are you doing?
Yeah, we can open it up if people want to ask. Also, we have a fairly small audience. Maybe I'll kick it off, Dieter.
Yeah,
In
go
terms
ahead.
of the FinOps, in general, the FinOps framework, and this whole FinOps movement that started a few years ago. When you look at the landscape, the industry, what is your what do you reckon is the maturity of the organizations in terms of that FinOps framework? Are they kind of early days, or where do you think they are?
You know, that is a very good question. And let me tell you one thing. First of all, you simply go to data.finops.org, right? The FinOps Foundation is part of the Linux Foundation, and it is a nonprofit organization. And I see the question by Anonymous, so I will answer that in just a moment, right? But it's roughly a 30-30-30 split, right, of maturity, crawl, walk, run. However, what we are seeing now, because I spoke to J.R. Stormont at reInvent in 2016, where he asked me, "Is this cloud financial management a thing?" And I told him the industrial kitchen example, right? And then in I believe in December or late in 2019, he actually founded the FinOps Foundation, and a little later, the FinOps Foundation joined the Linux Foundation, right? The FinOps Foundation now has over 10,000 members, and they are about 40 ambassadors last time I counted, right? So there's quite a few ambassadors, but compared to 10,000 members, it's still a relatively small number, right? What we are going to see is that in pre-pandemic, right, we saw some numbers from Andy Jassy where still 95% of all of IT is done in data centers, right? So this 95% is going to move into the cloud, right? And what we are seeing currently is that there's more and more very mature organizations, right? The Targets, the General Mills, the Walmarts, those kind of organizations that have very mature, right? I mean, Target has a FinOps team that is 25 plus engineers strong, right? With data engineers and data scientists, those kind of people, right? So you have these very mature organizations while you still get a continuous influx of wide-eyed new people, right, that are new to the cloud, that still think the trusted advisor is a great tool, right? While the people that have more seniority in the cloud hate trusted advisor because of its limitations, right? So we will see this continuous influx of newcomers to the cloud, right? While we do see now a very strong base of cloud native or people that are very knowledgeable about cloud, right? And these organizations are driving these cloud tools, right? For example, I built multiple forecasting systems that have less than 2% forecast variance, right? And I'm working with a startup right now that is going to hopefully build a forecasting system that has the same forecast variance, right? This would not have been possible 5 years ago, right? Because the knowledge base still wasn't there. So we are going to see a continuous influx of newcomers while we see much more mature practices as well. Did I answer your question?
Yes, thank you. There is an anonymous question here if you want to answer
Yes,
that.
let's go over that. I will read the question. It looks to be a team effort to bring the cultural change. Who should be owning up to drive within the organization? That is a traditional thinking, right? The correct answer is everyone is driving the cultural change. If you have well, except for executives, right? Let me explain. If you have one person drives the cultural change, he's basically like a cheerleader dancing around in front of people that don't want to do this, right? Or they are lacking the knowledge how to do this. They are lacking the motivation of how to do this, right? And if I don't know how to do something, I simply can't do it, right? And if I don't have a reason to do it, why should I spend my time, right? I get paid the same. Let's be honest. The executives, though, to get executive support is critical, right? And if you don't have executive support now, you can wait for a event in the future where maybe the CFO comes and says like, hey, cloud spend is growing faster than revenue, right? And then the executives get together, they run over the numbers, and all of a sudden, FinOps will become a priority. But the executives have to essentially support this cultural change, right? They have to understand the industrial kitchen principle. They have to understand that there is no end to this. They have to understand, and I see the second question from Anand as well. They have to understand that the technology changes, right? Improvement has to be continuous. Learning has to be continuous. Optimizations have to be continuous. Cleanup has to be continuous, right? If the executives don't understand that, then you need to wait until they understand. Fortunately, what many people don't know, there's actually groups where the executives meet on a monthly or quarterly basis and they exchange ideas, right? So maybe other executives can help them with that cultural change, that transition, right? But the owner is every single person, right? I just this week spoke to an engineer that said, like, I can't tell the other team to do this. And I'm like,
Yeah,
well, you don't need to tell them, right? You tell them, look, this is your opportunity, right? You can save $50,000 a month, right? So we're looking at 600,000 a year. This is your opportunity. Tell the director or the engineering lead, right, about this, and that's all you need to do. And then in a
yeah,
month or two, you ask again, hey, how is this going with this optimization? Have you guys looked into this, right?
yeah,
Well, hopefully the answer will be yes, we looked into this, and it's on our schedule. It's on the roadmap, right?
yeah. We have a couple of
Another,
minutes left.
yeah,
There's one question about energy here, and there's one more question that I have regarding KPIs.
yeah.
Ultimately, somebody needs to own the reduction of the cost. I know you said that a lot of people are involved, but in the organization, isn't there like one FinOps team that says, it's my job to make sure that I cut costs by this much? Does
It
that happen?
is, yes, it is. However, you own the recommendations. You don't own the implementation. And the FinOps team, I mean, whatever can be done centrally, we do centrally, right? Oh, by the way, I wanted to show this. Let me see this. Here's additional training before we forget, right?
Yeah.
So you can take a picture of this and then type in the URLs. This is all free training that is available. You don't own the implementation, but you own the recommendation and you own the follow-up on the implementation, right? Yes, there's one central FinOps team, but you need to partner with the engineering leaders. You need to partner with leadership. You need to partner with finance. Maybe you guys look at budgets versus actuals on a monthly basis, and then you reach out to those engineering owners and ask them, hey, you were slightly over budget here. What are you doing to compensate for that? To answer Anand's question, there are some technologies out there that actually compare regions when it comes to sustainability. And there are some technologies that are in the startup phase that are able to maybe move something from France to a more sustainable region, let's say UK, right? So I have seen this starting, that sustainability becomes, one of the drivers here when you have the options, right? When you can move from one data center to another. Let's say if you're in the United States, it may be impractical for you to move to Europe because then your latency will increase by 50 to 80 milliseconds for each request, right? But you can still look at, Microsoft Azure does that actually, that they have a sustainability map of their data centers. And if you so choose, you can move your workloads to a data center with a lower carbon footprint.
Yeah, thank you, Dieter. I think
Of
we're
course.
out of time here. And once again, Dieter, that was an incredibly valuable and insightful discussion. Obviously, you know this space quite well. And thank you really for sharing the time and
Absolutely.
being part of this webinar today. Folks, we'll wrap up. We will have one more follow-up webinar in about a month's time. And Dieter will be back and we'll be discussing a very innovative new solution that Platform 9 has been working on that actually solves many of the challenges that Dieter has been talking about in this webinar. So we look forward to seeing you in a few weeks.
It's a
Thank you very
very
much.
exciting solution, and I'm really looking forward to hearing more about it. Thank you so much for inviting me.